Questions 5 through 7 on the 2008 Grade 12 Euclid Math Contest. In the diagram, the large circle has radius 9 and center 15, 0. The small circles have radius 4 and centers A and B on the horizontal line y is equal to 12. Each of the two small circles is tangent to the large circle. It takes a bug 5 seconds to walk at constant speed from A to B along the line y equals 12. How far does the bug walk in 1 second? This diagram is at the heart of our solution, of course. So we'll start drawing lines. One line from A all the way to the center there, another line from B to the center, and I'm going to draw one more line to the top there. That's a perpendicular. And let's start labeling as much as we can. We are told that the radius is 9 for the big guy, and for the small circle it's 4. So this is 9 and this is 4, and therefore that whole distance will be 13 from there to there. That will be 13, so I'll just write that over here. Okay? And then top to bottom here, that's pretty straightforward. It's 12. How do I know it's 12? Well, because this line is y equals 12, and this was the x-axis. So this distance from here to here is 12. And then this distance, I don't know. That is something I need to calculate. This point I'll just call M for midpoint. And I think that's about all we really need to calculate this question. So here we go. Using Pythagoras, AM squared plus 12 squared is 13 squared, right? Because we're using this triangle. And therefore AM squared is 169 minus 144, and that is 25. So therefore AM is the square root of 25, which is 5. So this is 5. So therefore the whole distance AB is 2 times 5, which is 10. Right? From there to there is going to be 10. So they tell us that a bug takes 5 seconds to walk from A to B. So AB is 10. So AB over 5 seconds is the equivalent of a certain amount, a certain distance over how many seconds here? 1 second. Okay. So this is the ratio. AB we figured out is 10. So 10 over 5 is equal to x, and therefore x is equal to 2. So it takes the bug, in 1 second the bug will travel 2 units. I guess that's the best way of explaining it. Determine all values of k with k not equal to 0, for which the parabola y is equal to kx squared plus 5k plus 3x plus 6k plus 5 has its vertex on the x-axis. If the equation of a parabola is of the form y is equal to a x minus h squared plus k, then we can easily determine the vertex. It will be just hk. So there's several approaches to this question. I'll just do it the way I like to, which is I want to convert this into this form. If I do that, then I can hopefully just look at the h and the k, and then I can solve for k, which is, don't get confused. Ugh, terrible that I've used k and k, but don't worry, it'll make sense. So how do I get this thing into this form? Well, we do that by completing the square. All right, so that is something that I'm sure you're familiar with. Now, when I get this into this form, how is that going to help me, first of all? It'll give me the vertex, but how is it going to give me k? Well, here's the story. This is the sentence, part of the sentence that is very important. The vertex is on the x-axis. So, for example, let's say you have a parabola, and this is the parabola, right? And its vertex is right there on the x-axis. What does that mean? it means the vertex is of the form H0, because the vertex is on the x-axis, the y-coordinate is 0. So that means when you do get it into this form, this component will be 0. Okay? That is very important to understand in this question. So here we go. Let's proceed with this. First thing is, let's expand it all out and collect like terms. But I can see they've already done that, so the first thing to do is factor out the k. If I do that, I get x squared plus 5k plus 3 over k x. And this guy I can just leave alone. We don't really need that to complete the square. Okay? Now, how do we complete the square? You complete the square by taking half of this and squaring it. So it essentially will be 5k plus 3 over kx, but then you take half of this coefficient and square it. So half of that is 5k plus 3 over 2k, and then you just square it. And then you have to immediately subtract it, because you can't just add something to the equation. You can't change the value. All right? So it's not that complicated, hopefully. And don't forget the 6k plus 5. Now the good news is that these three terms will factor. So this becomes x plus 5k plus 3 over 2k all squared, right? And then this guy we can kick out, but don't forget to multiply it by the k before you kick it out. So it becomes minus 5k plus 3 all over 2k all squared, and because we kicked it out of the brackets, we have to multiply it by k. And there we go. So what does this mean? It means, I hope you remember, that in order for this to have a vertex on the x-axis, this part of the equation must equal 0. All right? As I had previously mentioned. So let's do that. Set that equal to 0. And I'll just put everything on one side, the negative part on one side. And then if I expand this, I get 6k plus 5. But then I'll bring this 2k squared over. I'll cross multiply it, so I get 4k squared up here, right? And then expanding that, I've got 25k squared plus 30k plus 9. And then don't forget that k. Now I can divide both sides by k, just get rid of that. We don't need that. So this just becomes 25k squared, 30k plus 9. And this becomes 4k because I divided by divided by k. And then 4k multiplied by this guy will give me 24k squared plus 20k. Okay, now let's put it all on one side. K squared plus 10k plus 9. And I believe this factors pretty nicely. K, 9, 1, negative, negative. Negative, negative, or plus, plus? Yeah. All right, so therefore, k is equal to negative 1 or negative 9. And that is what they're asking for in the question. Determine all values of k. So we got two values. We got k equal to negative 1 and negative 9. The function f at x satisfies the equation f at x is equal to f at x minus 1 plus f at x plus 1 for all values of x. If f at 1 is 1 and f at 2 is 3, what is the value of f at 2008? So we have this equation, f at x is equal to f at x minus 1 plus f at x plus 1. And I'm going to rearrange it a little bit. I'm going to write it as f at x plus 1 is equal to f at x minus f at x minus 1. It didn't change anything. I just reversed the order a little bit. Okay, so let's first make a little list here, f at 0 and going down. And as always with these kinds of questions, we have to eventually get a pattern, because there's no way we're going to go all the way until f at 2008, right? I mean, that would not be practical. So we get a pattern, and hopefully when we get a pattern, we can extrapolate to 2008. So some of these they already give us. F at 1, they already tell us is 1. F at 2, they tell us is 3. So now we get to F at 3, and that's where this formula comes in. F at 3 is basically F at 2 minus F at 1, right? You see how when you rearrange it, it's really quick. So it's basically just 3 minus 1, which is 2. All right, let's keep going here. F at 4 will be F at 3 minus F at 2. So that is going to be 2 minus 3, which is negative 1. No pattern so far, but no problem. Keep going. F at 5 is F at 4 minus F at 3. And that's negative 1 minus 2, which is negative 3. Negative 3 right there. F at 6 is F at 5 minus F at 4. And that is negative 3 minus 1. So that's negative 3 plus 1, which is minus 2. Okay, still no pattern. Oh boy. F at 7. F at 6 minus F at 5. And that is minus 2 plus 3, which is 1. Okay, now I don't have to write this out, right? I mean, F at 8 is basically F at 7 minus F at 6. So that's 1 minus minus 2, so 1 plus 2, which is 3. And then F at 9 is F at 8 minus F at 7, so this minus that, which is 2. F at 10 is 2 minus 3, negative 1. F at 11 is negative 1 minus 2, negative 3. F at 12 is negative 3 minus minus 1, so minus 2. Well, there we go. We just got a pattern. 1, 3, 2, negative 1, negative 3, negative 2. 1, 3, 2, negative 1, negative 3, negative 2. See how it repeats? So we got ourselves a pattern. Now we can extrapolate to F at 2008. Well, how do we do that? What I'm going to do is just look at whenever the number is a factor of 6, it is going to be the same, right? It's going to be negative 2. So the first thing is 2008 a factor of 6? 2008, is it divisible by 6, I guess? Same story. And the answer is no. Unfortunately, it's 334, but with a remainder of 4. So that means that F at 2004 is divisible by 6, a factor of 6, however you want to say it. So that means that will be negative 2, since all the factors of 6, multiples of 6, is going to result with negative 2. So all we have to do is just use the pattern to figure out the rest. F at 2005, F at 2006, F at 2007. Okay, no problem. F at 2005 will be the same as this guy, so that'll be a 1. F at 2006 will be the same as that, which is 3. F at 2007 will be the same as F at 9, which is 2. And finally, F at 2008 will be the same as F at 10, which is negative 1. So there we go. The numbers A, B, and C in that order form a 3-term arithmetic sequence. See below. And ABC is equal to 60. The numbers A minus 2, B, and C plus 3 in that order form a 3-term geometric sequence. Determine all possible values of A, B, and C. Well, if you're in grade 12, I'm certain you know what is an arithmetic sequence and what is a geometric sequence. So let's first start with the arithmetic sequence. It's ABC. Now we know that an arithmetic sequence is of the form A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. So that's what these are. But they also give us this equation that A plus B plus C is equal to 60. Okay, no problem. That's very helpful. I can just substitute these guys in there. And if I do, I get A B is A plus D, and C is A plus 2D. And that equals 60. So that means 3A plus 3D is equal to 60, and therefore A plus D is equal to 20. Now A plus D is the same as B, so that means B is equal to 20. So there you go. In a very quick way, we got the actual numerical value for B. So now to figure out A and C, I have to use this information in the second sentence. And that is that this time A minus 2, B, and C plus 3, these form a geometric sequence. And geometric sequences, if you remember, are of the form AR squared, like that. Right? Where R is some common ratio. Okay, so where do we proceed now? Well, if you look at geometric sequences, you'll notice that if you take the second term and divide it by the first term, it equals R, right? Because the A's cancel. And if you take the third term and divide it by the second term, again, you get just R, because the A and the R will cancel. So that means in this scenario, with these values, we can do the same thing. And hopefully that will help us. So that means that B over A minus 2 is the same as C plus 3 over B. All right? I didn't do anything fancy, just working with that aspect of geometric series. So cross multiplying, I get B squared is equal to A minus 2 times C plus 3. The good news is B, we know the actual numerical value, so B squared is going to be 400. A minus 2, C plus 3. So at this point, we can make a table and move forward. All right, so we've got A minus 2, C plus 3, and then we can figure out the values of A and C, and then B is always going to be 20, right? Because we figured that out up here. So how do we use this equation to figure out A and B? Well, this times this has to equal 400, and these are all integers, right? So what are the possible ways to get 400 when you multiply two integers? Well, we can have 401. We can have 202, 104, 80, and 5. Right, remember these have to be integers. 50 and 8, 10 and 40, 16 and 25, 20 and 20, and then we kind of get the same things, 25, 16, right? These just reverse. So I think that should be good enough. We'll get a pretty good idea with these guys if we need to keep going, right? Because everything below that line I just drew is going to just be a flip of what I already wrote. All right, so here we go. We can start filling in these values. If A minus 2 is equal to 1, that means A is going to be 3. If C plus 3 is equal to 400, that means C is 397, right? So in a very similar way, we figure out all these values. Very quickly, we can do that. 6, 7, 10, 12, 18, and 22, and 27. And the corresponding values for C are 97, 77, 47, 37, 22, 17, and 13. Okay. Now, you say, okay, well, that's all the solutions, right? Well, no. The answer is no, they're not all the solutions. Why? Because remember, A plus B plus C has to equal 60. And since B is 20, that basically means that A plus C has to equal 40. So the only solutions are the ones that are going to satisfy that. All right, well, obviously, this is not going to be, a solution. That's way too big, right? But how about this guy? 37 and 12? No, that's not going to be 40. But this is 40. 18 and 22 is 40. And then what about 17 and 22? Ooh, that's close, but nope. And what about this guy? 13 and 20. Yeah, that works. And then if you keep going like this, right? Like these will just be flips. So this will be like 10 and 40. What you'll notice is that these numbers will be the same for A and C, but they will just be flipped all the way down. They'll be flipped. So if you calculate them, you can do so if you really wanted to. This will be 42, and this will be 7. But immediately you'll notice that as you go down, A plus C is never going to be 40. It will always be greater than 40. So you don't really need to figure all those out. So the only ones we got are the ones I just circled. So A, B, C is 18, 20, and 22. That's the first one. And A, B, C can also be the second one, which is 27, 20, and 13. And you can go back and verify this just to make sure that you got the right answers to the question. And indeed we have. So there you go. Those are the only possible values for A, B, and C that satisfy all the requirements of the question. The average of 3 consecutive multiples of 3 is A. The average of 4 consecutive multiples of 4 is A plus 27. The average of the smallest and largest of these 7 integers is 42. Determine the value of A. So a multiple of 3 is going to be of the form 3x. And then they have 3 consecutive multiples of 3. So you have 3x, you have 3x plus 3, the very next one, and 3x plus 6, right? Those are my 3 consecutive multiples of 3. And they're saying that the average is equal to A. So 3x plus 3x plus 3 plus 3x plus 6 divided by 3 is equal to A. All right, let's see. What can we do here? 9x plus 9 is over 3 is equal to A. That means 3x plus 3 is equal to A. And I think that's about as far as I can go there. Now let's look at the second sentence, and that sentence says that the average of 4 consecutive multiples of 4 is A plus 27. So a multiple of 4 is of the form 4n. And then the next one would be 4n plus 4, 4n plus 8, and then 4n plus 12, right? And they're saying that the average of this is A plus 27. So you add them up, divide by 4, and if you collect like terms, you will get 16n plus 24 over 4 is equal to A plus 27. And can we do anything? Yeah, we can divide through by 4, so this just becomes 4n plus 6 is equal to A plus 27. All right, so I got this equation and that equation. All right, way too many variables, right? Okay, so what do we do now? What are we trying to find here? Oh, the value of A. Okay. So, too bad there's one variable too many, right? Because you have 2 equations, but you have 3 variables. So that means we have to do casework. Okay, no problem. But I can combine them, right? Because if I've got an equation 4n plus 6 is equal to A plus 27, this A, I can just put 3x plus 3. So 3x plus 3 plus 27. That way, I get rid of the A. I'll look at x and n, and then I can go back and figure out A. So simplifying, this becomes 4n is equal to 3x plus 24. All right. There we go. Now I've got to make a table and start plugging away values. So I've got x and I've got n. So here we go. Let's start. And they have to be integers, right? Yeah, because they're talking about integers. 7 integers, right? Okay, good. All right, so let's start with 1. If x is 1, we get n equal to 6.75, and that's no good. All right, how about when x is 2, we get 7.5, and again, that's no good. When x is 3, we get 8.25, and that does not help us. 4, we get 9. Okay, great. We got a solution. X is 4, n is 9. So let's see if that will solve properly, if this makes sense. And in particular, the third sentence. So if x is 4, then that means my numbers are 12, 15, and 18. And if n is 9, my numbers are 36, 40, 44, and 48. Now, this sentence has to hold true. Otherwise, this is no good. I got to keep going. And that is the average of the smallest and largest of these 7 integers is 42. Okay, what is the smallest and largest? It's 12 and 48. The average of 12 and 48 is what? 60 over 2, which is 30. And that's not 42. Okay, no problem. So that means that this is a dud right here. Okay, not an issue. We can just keep going. Keep going, and one thing I notice is that to speed up the math, x has to be a multiple of 4 to give an integer value for n, right? I think you can figure that out just from this equation. So instead of going 5, 6, 7 and wasting time, let's just jump all the way to 8, because that's the only way you can get an integer value for n. And when x is 8, the integer value for n is 12. All right, so now let's figure out the numbers for x equal to 8 and n equal to 12. If x is 8, this becomes 24, 27, and 30. When n is 12, this becomes 48, 52, 56, and 60. So now let's see if this sentence holds true, which is the average of the smallest and the largest is equal to 42. 24 plus 60 is 84. 84 divided by 2 is indeed 42. Great. So this is my values for x and n. So I have to figure out the value of a, right? That's the ultimate goal here. So a is equal to, you can use that one or this one, doesn't really matter. 3x plus 3, x we figured out was 8, so that's 3 times 8 plus 3, and that is 27 for a. Billy and Crystal. The full name Billy Crystal, that exact spelling is the name of a famous actor who also used to host the Academy Awards for many years. Billy and Crystal each have a bag of 9 balls. The balls in each bag are numbered from 1 to 9. Billy and Crystal each remove 1 ball from their own bag. Let B be the sum of the numbers on the balls remaining in Billy's bag. Let C be the sum of the numbers on the balls remaining in Crystal's bag. Determine the probability that B and C differ by a multiple of 4. Billy has the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. And Crystal also has the exact same numbers. Now, we are going to make a systematic approach to this question, hopefully as clear as possible. So we have to make a little bit of a table once again. Tables are great. And here we go. So first let's talk about Billy. We're going to put first the removed ball number. And of course we can remove either the 1, the 2, the 3, the 4, the 5, the 6, the 7, the 8, or the 9. Right? You're only removing 1 ball. Remove 1 ball. That's it. And then in this we're going to have the sum that is remaining. The remaining sum. Well, first of all, what is the total sum? 1 all the way to 9, 1 plus 2 all the way up till 9 is equal to 45. Right? So if I remove the 1, what is my remaining sum? Well, 44. And similarly, if I remove a 2, the remaining sum would be 43. And so on down, 42, 41, like that. And the good news is, for Crystal, it's the exact same story. We have which ball did you remove, and what is the remaining sum. And it is the exact same story for crystal. You can remove any of the first, any of the 9 balls, and the remaining sum is going to correspond in the same way. So like any probability question, our probability is going to be a fraction, and the bottom number is the total number of ways of doing this. And the top number is the specific condition. Now, the total number of ways of doing this is, for the Billy, we can remove any one of 9 balls, so we have 9 possible choices. For crystal, again, we can remove any one of 9 balls, so again, another 9 choices, and you multiply them. So that means that when you do that probability, the denominator is 81. That's pretty straightforward. But the numerator is our specific condition, and that is that B and C differ by a multiple of 4. Now, what is B? Let's remind ourselves. B is the sum of the numbers remaining in Billy's bag. So B is this guy right here. This is B. Any one of these. C is the sum of the numbers remaining in Crystal's bag. So C is here, any one of these numbers. And we have to figure out all the scenarios that when you take the difference of B and C, the difference is a multiple of 4. So we have to do casework, but it shouldn't take too long. So here we go. Let's start off with 44 for Billy. If you have 44, then we have to subtract C. Well, let's say C is 44. The difference is therefore 0. Okay, is 0 a multiple of 4? The answer is yes. 0 is a multiple of anything. Now we keep B as 44. Now remember, what I'm doing is just B minus C. I'm going to look at B minus C for each of these. But the good news is we don't have to go through all 81 because that would be very time consuming. You'll quickly see there's a quick pattern. 44 minus 43, I don't really care because I only care about multiples of 4. How do I get a multiple of 4? By going down to 40. 44 minus 40 is 4, and that is what I'm interested in. That's a multiple of 4. And for 44, the next one that will give me a multiple of 4 is if I chose 44 for B and 36 for C. That is a multiple of 4 because that's 8. So there we go. We just got 3. And then we drop down to 43. And this will be fairly quick. 43, if I choose 44, I don't care. I don't need to do that one, but I do need to do the 43 and 43 combination. Why? Because that gives me 0, and that's a multiple of 4, so I have to include that in my list. The only way else to get 43 and a multiple of 4 is to subtract 39. So there we go. That's 4, and I'm done with 43. Only 2 of those. Now we drop down to 42 for B, and very quickly you'll realize that 42 minus 42 and 42 minus 38. Those are the only 2 that will give me a difference that is a multiple of 4. All right, so I think you're getting the hang of this, but I'll just go through them. I'll do it pretty quickly. 41 minus 41, 0. 41 minus 37, 4. Those are the only 2. Okay, 40. Now this one is the most likely one to miss students because they're thinking, oh, it's 2, 2, 2 all the way down. But 40 gives you 3. Watch, 40 minus 44 is actually minus 4. That is a multiple of 4. 40 minus 40, that gives you 0. And 40 minus 36, that gives you 4. So you get 3 for that. Okay? And we've just got a few more. We'll just rush through these. 39 minus 43 gives me negative 4. 39 minus 39 gives me 0. We got another 2 there. Then we got 38. 38 minus 42 gives me negative 4. And then 38 minus 38 gives me 0. Another 2 there. And then, what's the next one? 37, right? 37 minus 41, that'll give me negative 4, and 37 minus 37 gives me 0. And then the last one is going to be 36. That minus 44 gives me negative 4. 36 minus 40 gives me negative 4. That one was negative 8, sorry. And finally, 36 minus 36 gives me 0. So this one gave me 3. So I add it all up. All of these guys, if you add them up and this, you get a total of 21. Right? Because it's 3 of these 3's and then 1, 2, 3, 4, 6 2's. And that's 9 plus 12, which is 21. So 21 that meet our specific condition. So that's the probability. And in lowest terms, you'd divide top and bottom by 3. And you get 7 over 27. So that's the probability for this question.